Hi, Ray, and welcome to your second lesson in rates of reaction. Please make sure you have a pen and paper ready to answer any questions and take any notes. So your starter question for today is a 3-minute long one, so pause the video for 3 minutes and answer the question. A chef is wanting to make some mashed potatoes quickly ready for service. To do this, they need to boil the potatoes until they are soft. Should the chef put the potatoes in the boiling water whole or cut them up? Explain why. If you're not sure how to answer this, look back at our last lesson where we looked at surface area. So we're just going to quickly review the answer for the starter question. So you should have put that the chef should cut the potatoes up. The reason for this is that it will increase the surface area of the potatoes. Now, with an increased surface area, they will be able to react with the hot water or cook faster as there are more successful collisions between the particles. So remember that most cooking is in fact just chemical reactions, so increasing the surface area of those potatoes by cutting them into smaller pieces will mean that they will cook or react faster because there's more successful collisions. So that's a little review on what we did last lesson. So as I said, last lesson we looked at the collision theory or the principles of collision theory. We also looked at the effect of temperature on rates of reaction, and we looked at the effect of surface area on rates of reaction. Today we're going to be looking at the effect of concentration on rates of reaction. We're going to explain the effect of catalysts on rate of reaction, and we're going to explain the effect of pressure on rates of reaction. So those three things we're looking at today: concentration, catalysts, and pressure, and how they affect the rate of reaction. So just to give you another brief overview over collision theory, because this is what underpins everything that we're going to be doing today. So collision theory states that for chemicals to react, the molecules need to collide with enough energy. So when we put two reactants together, those particles inside those reactants are going to collide, and if they have a successful collision, a new chemical product will be made. If they have unsuccessful collisions, then they will just simply bounce off of one another. But what we want to do is we want to increase the amount of successful collisions, which will increase our rate of reaction. Now, in order to do this, we need to make sure that the particles collide with sufficient energy. It's also affected by how the particles are orientated, but what we're going to be focusing on is simply increasing the amount of collisions, because that will make the amount of successful collisions more likely. And what we're going to do is we're going to look at our three factors: concentration, catalysts, and pressure, and see how they affect the amount of successful collisions that we have between particles. The first one that we're going to be looking at today then is concentration. Okay, now concentration tells us how much of a solution contains a certain chemical. Now, to give you an example, for instance, our acids are typically dissolved in water. So a dilute acid would have far less of the acidic chemical in a given volume compared to that of a concentrated acid, which would have more. So if you imagine you have 100 milliliters or 100 centimeters cubed of your acid, in a dilute acid there will be far less acid particles compared to 100 centimeters cubed or 100 liters of a concentrated acid. So just to give you a visual example of what that would look like, if you look at the diagram on the right, you can see in the left part of the diagram we have very few molecules, and if we imagine then that our green particles there are our acidic particles, we can see that there are less of them in that given space. But if we increase the concentration and look on the right side, we can see that we have far more of those green particles there, and those are our acid particles. So the one on the left would be a dilute acid solution, and then the one on the right would be a concentrated solution. Now, concentration will affect the rate of reaction. Now, the way that it does this is that concentrated substances have more of a chance of reacting with the other chemical that they have been interacting with. The reason for this is that because simply there are more of those active particles there. So give you an example then, if we were to react an acid with a metal, for instance, if we have a more concentrated acid, that means that there are more acid particles there. And that means that it's more likely that acid particles are going to collide with the metal and have a successful collision, producing a new product. Okay. However, if we used a dilute acid, it would be the opposite. There are less acid particles there, which means that it is less likely to have collisions with the metal. And if it's less likely, there'll be less successful collisions, leading to a slower rate of reactions. So when we increase concentration, we increase the amount of particles there that can react, and that in turn will speed up the rate of reaction because more successful collisions are going to occur. So what I want you to do then is I want you to use that information from that slide there to try and answer this exam style question. So it's a 4 marker, so you're going to need 4 minutes for it, so you're going to need to pause the video for 4 minutes. A student has 2 samples of sulfuric acid. One is concentrated and the other is diluted. The student wants to react some magnesium metal with the acids and compare the rates. Explain which acid will have a faster rate of reaction and why. So, what we should have for that answer there, and make sure to fill in any parts that you don't have, any points that you haven't got, make sure you fill them in. So for your first mark, you need to simply state that the concentrated acid will have a faster rate of reaction. That's mark 1. This is because the concentrated acid has more acid particles in a given volume. So that's your second mark. Remember, a given volume is referring to a space. This means successful collisions are more likely in the concentrated acid as there are more acid particles, and there are more acid particles available to react. So that's your third mark. This will increase the rate of reaction. That's all you need for your fourth. So make sure if there's any parts on there that you haven't got, make sure that you have added them to your answer. Second factor that we're going to look at then, so we've looked at concentration. Second one is catalysts. So we're going to have a look at catalysts now. Now, a catalyst is a specific chemical term, and it is defined as a chemical substance that can speed up the rate of reaction without being used up or chemically changed in a reaction. So for instance, if I was to have 2 chemicals reacting together and I add a catalyst, theoretically I should be able to put my catalyst into that reaction. It will speed up the rate of reaction, and then I should be able to take my catalyst out of that reaction. And the catalyst itself should not be chemically changed in any way. For instance, if my catalyst was, say, silver or something like that, and I put it into my reaction, I put a bar of silver in there, theoretically I should be able to then take that out at the end of the reaction, and it should be chemically identical. There should be no change. Now, it's important to note that catalysts do not increase how much overall product is made, just the speed at which it is produced. Okay, so if you're going to do a chemical reaction and you can estimate how much stuff you will produce at the end, how much product you'll produce at the end, your catalyst won't change how much you get at the end. It will still be the same as if you did it without a catalyst. However, it just drastically improves the speed at which you produce that product. Now, the way that catalysts do this is by providing what's called an alternative reaction pathway, which requires less energy. Now, what that means is it allows for more successful collisions to occur because it reduces the amount of energy that the chemicals need in order to react. So remember, when we talk about collision theory, we say that the chemicals need to firstly connect in the right orientation, that is to say the right shape, but they also need to have sufficient energy in order for that collision to be successful. Now, what catalysts do is they essentially reduced the energy cost needed, and that means that more of the particles in the reaction have the necessary energy needed to react. So if you look at the diagram, you can see on the right there, we've got our reactants on the left, we've got our products on the right, we have our energy on the y-axis, and on the x-axis, although it's not labelled, we would have time or progress of reaction. Now if you look, the energy cost for the reactants to become the products without a catalyst is quite high. So you can see that there is a big hump in that energy graph. So what we have to do is we have to increase the energy, or what's called the activation energy. We have to reach that point so that we can trigger the reaction. However, when we use a catalyst, that energy, that activation energy, is significantly lower. It's a lot lower, and that means that more of our particles are more likely to have the necessary energy needed to react. So that means that we will have more successful collisions because the energy needed for a reaction to be successful is lower. So what will happen is our chemicals will come along, they'll bind on the catalyst, and what we'll see is that the energy needed for the reaction to occur is lower, and that means we get more successful collisions. So your second exam style question then, what I would like you to do, and it's a 5 marker, so you're going to need to pause the video for 5 minutes in order to answer this. I want you to define what a catalyst is and explain how a catalyst influences the rate of a reaction. So here is your answer for question 2, and I've broken it up into 2 parts just so it's a little bit easier to see where the marks are coming from. So the first mark is for defining what a catalyst is. So a catalyst is a substance that can speed up the rate of a reaction without being used up or chemically changed in the reaction. That's for your first mark. Catalysts increase the rate of reaction. That's 2. They do this by providing an alternative reaction pathway that requires less energy. That's for your third mark. As the energy cost is reduced, more particles have the necessary energy needed to react. That's your fourth mark. This leads to more successful collisions and a faster rate of reaction. That's mark number 5. Okay, so remember, if there are any parts in that answer that you have not got written down, please make sure you add them to your answer. Okay, so we've looked at concentration, we've looked at catalysts, and there is one other factor that we need to look at here, and that is pressure. Now, pressure is slightly different to the other factors, so the ones that we've looked at in total are temperature, surface area, concentration, and a catalyst. Pressure is unusual in that it only affects reactions between gases. So if we increase the pressure of 2 liquids reacting together, or a solid reacting with a liquid, it won't actually do much to the rate of reaction. Pressure, however, will greatly affect any reactions between gases. Now, if you increase the pressure, what you do is you reduce the space in which the gases can move. And if there's less space, that means that there is more likely to be collisions, and more collisions means more successful collisions, leading to a faster rate of reaction. So just to give you an example then, if you look at the diagram on the right, you'll see that on the left-hand diagram, there is more space for the particles. So the particles are moving around and they have a little bit more space, which means that they can move around and bump around the container and not interact with one another. However, if you increase the pressure, so reduce the space in which those gases can move, suddenly there's no space for them to move about, and that means that collisions are far more likely. So what I want you to do now is have a go at answering this exam style question 3. Now this one is broken up into 2 parts, A and B. Remember, it's a 5 mark total, so you're going to need to pause the video for 5 minutes in order to answer it. A very common chemical reaction in industry is the Haber process. In this reaction, hydrogen gas is reacted with nitrogen gas to form ammonia. So, part A of the question. Explain how increasing the pressure of this reaction would affect the rate at which ammonia is produced. And part B, explain if this would have the same effect on liquid hydrogen reacting with liquid nitrogen. So the first part is 3 marks and the second part is 2 marks, 5 marks total. So your answer for question 3. So for part A, for the first mark, you need to identify that increasing the pressure of the reaction would increase the rate of reaction. So the rate at which ammonia would be produced is increased. You also need to explain. So this is because there is less space for the hydrogen and nitrogen particles to move in. That will get you your second mark. This makes more successful collisions more likely. Okay, so when you reduce the space, that means they're more likely to collide. If they're more likely to collide, we're more likely to get successful collisions, leading to a faster rate of reaction. So that is your third mark. Now for part B, it's broken up into 2 bits. So it asked whether or not we would have the same effect in a liquid reaction, so liquid hydrogen reacting with liquid nitrogen. And you need to say for the first mark that this would not have the same effect, okay? And the answer for this is that liquids cannot be compressed in the same way that gases can, okay? So remember, last lesson we looked a little bit at solids, liquids and gases, and we identified that gases were the only ones that were able to be squashed. Liquids and solids, however, are unable to be squashed, and that means that when you try and increase the pressure, try and compress a liquid, you're not going to get very far. The liquid particles are already all together and touching more or less, which means that you can't really force them any closer together. So when we increase the pressure, it's not really going to affect the rate of reaction because the particles are still moving about the same as they were before. But in a gas, you are reducing the amount of space in which they can move, which means that those collisions are more likely. So just to go over that again, so for B, it would not have the same effect on a liquid reaction, and the reason for this is that liquids cannot be compressed in the same way that gases can. That's for your 4th and 5th mark. So let's just quickly overview what we have covered so far today. So the 3 things that we were looking at were concentration, catalysts and pressure, and how they affect the rate of reaction. So we established then that concentration affects rate. So if we increase the concentration of a chemical in a reaction, we're going to increase the rate of reaction. The reason for this is when you increase the concentration of your substance, you increase how many of those substances particles are there, and that means that collisions are more likely. More likely to have collisions means a faster rate of reaction. We also had a look at what catalysts do to rate. So when we introduce a catalyst to a reaction, what we do is we increase the rate of reaction. This happens because a catalyst provides an alternative reaction pathway which requires less energy, and that increases the chance of particles colliding with enough energy in order to react. So catalysts reduce that initial energy cost for a reaction to occur, and that means that more particles will have the energy they need in order to have a successful reaction. And then our last one is about the effect of pressure on rate. Remember that increasing the pressure in reactions between gases will increase the rate of reaction. However, the effect of pressure on liquids and solids will not affect rate. Pressure will only affect reactions between gases. The reason for this is that increase in pressure pushes the particles closer together, so the particles of a gas closer together, and that makes the collisions more likely. More collisions, faster rate of reaction. Right, that brings us to a close. Thank you, Year 8.